Now we have theorem 1.28, properties of measures. Let X capital I mu be a measure space. Then the following holds. I mu of the empty set is equal to 0. Double I, if n is a natural number and A1, A2, An are in capital A such that the intersection between AI and AJ is equal to the empty set for A is different from J, then mu of unions of A1, A2, An is equal to mu A1 plus mu A2 plus mu An. The next statement. If A and B are in capital A such that A is a subset of B, then mu A is less than or equal to mu B. The next statement. Let AI is in capital A. AI is in capital A. Let AI be a sequence such that AI is a subset of AI plus 1 for all I. Then mu of the unions of AI is from 1 to infinity is equal to lim mu I tends to infinity. And the last statement. Let AI be a sequence such that AI plus 1 is a subset of AI for all I. Then mu of A1 is less than infinity. It implies that mu of the intersection between I is from 1 to infinity is equal to lim mu I tends to infinity. Proof. We prove I. Choose A1 is in capital A such that mu A1 is less than infinity, and define AI is to the empty set for I is greater than 1. Then it follows from sigma additivity that mu A1 is equal to mu A1 plus 6, the sum of mu of empty sets I is greater than 1, and hence mu's empty set is equal to 0. This proves part 1. Part 2 follows from part 1 and sigma additivity by choosing I is equal to the empty set for I is greater than n. We prove the third statement. If A, B are in capital A such that A is a subset of B, then B minus A is equal to capital A by property G in lemma 1.2, and hence mu B is equal to mu A plus mu B minus A. That sum is greater than mu A by part 2. This proves that part 3. We prove the next statement. Assume AI is a subset of AI plus 1 for all I, and define B1 is equal to A1 and BI is equal to AI minus 1 for I is greater than 1. Then BI is measurable for all I, and for n is a natural number. An is equal to unions of BI, I is from 1 to n. I is equal to unions of AI, I is from 1 to infinity, and is equal to unions of BI, I is from 1 to infinity. Since the intersection between bi and bj is equal to the empty set. For a is different from j, it follows from sigma additivity that mu a is equal to the sum of mu bi is from 1 to infinity. That is equal to lim the sum of mu bi is from 1 to n, lim n as n tends to infinity, and is equal to lim mu n tends to infinity. And the last equation follows from part 2. This proves part 4. Now we prove the last statement. Assume AI plus 1 is a subset of AI for all I, and define CI is equal to AI minus AI plus 1. Then CI is measurable for all I, and for n is a natural number. N is equal to A, the unions of A, and the unions of CI is from n to infinity, and I is going to the intersection between I is from 1 to infinity. Since CI, the intersection between CI and CJ is equal to the empty set for I is different from J, it follows from sigma additivity that mu n is equal to mu a plus the sum of mu ci is from n to infinity. For all n is a natural number. Since mu a1 is less than infinity, it follows that the sum of mu ci is from 1 to infinity is less than infinity, and hence we have lim mu n tends to infinity is equal to mu a plus lim the sum of mu ci is from n to infinity, n tends to infinity, and is equal to mu a. The proof, part 5 and theorem 1.28.